Okay, welcome ladies and gentlemen. We are busy showing that the left limit as x tends to 1 of g of x is equal to 6, where g is defined as that. And we have written out our proof outline. So now let's write out our proof. So let us start over here and let us consider this expression that we're interested in to finally have less than epsilon. So let us consider g of x minus 6. And for the time being, I'm going to erase that. Okay, but now let us expand this. X we've assumed to be to the left of 1. So g takes on the value to the left of 1 of x squared plus 2x plus 3 minus 6. Let us simplify that. X squared plus 2x minus 3, and that factorizes as follows: x plus 3 and x minus 1 in absolute value. Okay, and here we see something that has to do with 1, and in fact, what can we say about this absolute value? So if we think about what is going on here, x minus 1. So let's just think about our assumption here. So x, let's take this 1 across. X minus 1 is negative. So this absolute value is equal to x plus 3 in absolute value, but 1 minus x, which is this expression inside the absolute value multiplied by minus 1. Why by minus 1? That is because that is exactly how the absolute value is defined. It takes negative numbers. If you give it a negative input, it multiplies the negative input by minus 1. So this is what we get. Okay, so now this thing, let's see, where else do we want to get this thing? 1 minus x. If we think about what is going on here, let's take our x across. So 1 minus x is less than delta. So from our assumption, you see, if we take that across and take that across, we see 1 minus x is less than delta. So this is less than x plus 3 less than delta. And this is from our assumption. Okay, and now we're in the situation as before. You see, we have control over this delta. We are free to choose what it is. If we can only bound this factor, or this expression, absolute value of x plus 3, by a constant. And what is the obvious thing to do? I'm going to write it down here. So consider x to the left of 1 but to the right of 0. So what are we doing here? We are restricting our view to this interval here. And on that interval there, x plus 3 in absolute value has this intercept there, and will go up to 4 there. So and it will, if you look at its graph, it will look something like that. So I claim So we claim that x plus 3 in absolute value, let's say if x is in this interval, then x plus 3 in absolute value is less than 4. And let's see this happen. So assume 0 less than x less than 1. Then what have we got? We're looking for an x plus 3, so let's plus 3 everywhere. So that is less than 4, that is less than 3. And here we see this expression, if we take the absolute value at x plus 3, this is less than the maximum of these two values, so that is 4. So if x is between 0 and 1, then this expression is less than 4. So we got to bake in a 1 here for our delta. Okay, and then so let's say the minimum of 1, and now we need something else. So if delta is defined as such, then delta is certainly less than 1 because it is defined to be the minimum, and delta is less than or equal to whatever else we're going to put in there. And if we assume that delta is less than or equal to 1, then what we have here is we automatically get that x is less than 1 but greater than 1 minus delta. But if you take that across, 1 minus delta, that is greater or equal to 0. So we automatically get that 0 is less than x, which is less than 1. So 0 is less than x is less than 1. So let's call this star. So by star, this, by star and let's call this A. So by star, we have that x is between 0 and 1. And by A, we have that if x is between 0 and 1, then x plus 3 is less than 4. So by star and A, so star tells us that the hypothesis of A is true, therefore we have that the conclusion of A is true. That is less than 4 delta. And now we see here, what do we have to choose our epsilon as? We want to have our epsilon as actually we want to choose our delta as epsilon over 4, so we have to bake in an epsilon over 4 in there. Then delta is less than or equal to epsilon over 4, and here we use this double star here. So double star, so by double star over there, and that is equal to epsilon. And we conclude that g of x minus 6 is less than epsilon. I'm just thinking it would be useful here by a below, so that whoever is reading your work knows to go down to look for the a below. Okay, and this completes the proof of this example. I will see you in the next one.